We need to write a linear equation. We have two different options we can use. We can use slope-intercept form, which is y equals mx plus b. It's called slope-intercept form because in order to use it, we need to know the slope and we need to know the y-intercept. Our other option is to use point-slope form. Point-slope form says y minus y1 equals m times x minus x1, and it's called point-slope form because to use it, we need to know the slope, and we need to know any point, an ordered pair made up of any x value with its corresponding y value. When we have a picture of a graph, typically, we will be able to see the y-intercept along with the slope. If you can see the y-intercept well, we will use slope-intercept form. If we can't see the y-intercept well, then we'll use point-slope form. In each of these examples, we will be able to see the y-intercept. So for the first graph, the line crosses the y-axis at 2, which means our y-intercept is 2. To find our slope, we'll use rise over run. And so our rise, we're actually going down by 3 and over by 4. We're running 4. So our rise over run, or our slope, is negative 3/4. And since we know the slope and the y-intercept, we can plug that into slope-intercept form. Y equals our slope times x plus the y-intercept. For the second example of the graph, our y-intercept is 4. That's where it crosses the y-axis. And to find our slope, we'll find another good point on our graph, and we'll use rise over run. In this case, we are rising 4, running 2. So our slope is 4 over 2, which is 2. So our equation in slope-intercept form would be y equals 2x plus 4. For our final graph, our axes aren't labeled. So we're going to assume that both the x-axis and the y-axis are going up by 1s. So our y-intercept is at 2 if we're going up by 1s. And then I'm going to grab another good point right here. Our slope is negative. We go down 1 and to the right 2. So our slope is negative 1/2. So in slope-intercept form, we would have y equals negative 1/2 x plus 2. If we don't know the y-intercept, then a lot of times we'll need to use point-slope form instead, where instead of the y-intercept, we can know any point. So for this first equation, it tells us that the slope is negative 1. That's our m. And it tells us that the point is 3, negative 2. So we have an ordered pair. We're going to plug those into point-slope form, which says y minus our y value, which in this case is a negative 2, equals m, which is our slope, times x minus our x value, which in this case is 3. We're just plugging in what we know. So this is y plus 2 minus a negative is a plus equals negative 1x plus 3. I'm distributing that negative 1. And then the last step, I'm going to go ahead and isolate the y to put this into slope-intercept form. It doesn't say we need to put it into slope-intercept form, but I'm going to go ahead and practice doing that. So that would be our equation in slope-intercept form. The next one, we actually don't need to use point-slope form because the point 0, 2 is the y-intercept. Y-intercept happens when our x is 0. So our y-intercept is 2. Our slope is negative 4. We can go ahead and put that into slope-intercept form. But if you didn't know that that was the y-intercept, you could certainly start by putting that into point-slope form with the 0 in for x. But you'll find that in slope-intercept form, you will still get an answer of y equals negative 4x plus 2. Next one, I'm going to plug that into point-slope form. So I have y minus the y value. That is, negative 6 is not our y-intercept. It's actually our x-intercept because the y value is 0. So y minus 0 equals 1/3 times x minus negative 6, or x plus 6. Y minus 0 is just y. I'm going to distribute the 1/3 x plus 2. So our equation in slope-intercept form is y equals 1/3 x plus 2. If we are given 2 points instead of a point in the slope, our first step needs to be to find the slope. Because whether we are using slope-intercept form or point-slope form, we need to know the slope. So I'm going to go ahead and label my x's and my y's. And to find the slope, we find the change in y over the change in x. So I'm going to do 6 minus negative 4 to find my change in y. Because I use the 6 first in the numerator, I'm going to use the 3 first in the denominator to get 10 over 5, which is 2. So now that I have my slope, I need the y-intercept, but I'm not given the y-intercept. So instead, I'm going to use point-slope form. I was given 2 points, so I get to choose which point I want to use. I'm going to choose the first point. So point-slope form says y minus our y value equals m times x minus our x value. So this is our equation in point-slope form. I'm going to go ahead and take it a step further and change it to slope-intercept form by distributing the 2 and adding 6 over. So we just have y equals 2x in slope-intercept form. I'm going to go through the second example a little bit quicker. To find the slope, I'm going to find the change in y, which is 1. 5 minus 4 is 1, over the change in x, which is 2. Negative 2 minus negative 4 is 2. So our slope is 1/2. I get to choose my point. I'm going to choose the second point this time. So y minus the y value equals 1/2 times x minus the x value, which is negative 2. That minus and negative is going to turn into a plus sign. So that's our answer in point-slope form. And then in slope-intercept form, I would distribute the 1/2 to get 1/2 x plus 1, and then add the 5 over to get 1/2 x plus 6. So on these, we're basically asking for the same thing. They're just written in function notation instead. So if f of 4 equals negative 2, that means the function f has a value of negative 2 at 4. Or in other words, our input is 4 when our output is negative 2. Or when our input is 4, our output is negative 2. That's the ordered pair 4, negative 2. Similarly, when our input is 8, our output is 4. That's another ordered pair. So when we're solving this, we're just going to find the slope using change in y. So change in y over change in x. We get 6 over 4, which does reduce to 3 over 2. So our slope is 3/2. And then I can pick a point to use point-slope form since I'm not given a y-intercept. So point-slope form, I would have y minus 4 equals 3/2 times x minus 8. When I distribute, I get 3/2 x minus 12. And when I add 4 over, I get 3/2 x minus 8. Doesn't really specify that it needs to be in slope-intercept form, so either one of these would be fine. The next one, we've got 2 points, 2, 3, and 6, 5. If I find the slope, my change in y is 2, my change in x is 4, so that's 1/2. When I use point-slope form, I'll use the point 2, 3. Y minus 3 equals 1/2 times x minus 2. So y minus 3 equals 1/2 x minus 1, or y equals 1/2 x plus 2. Next, we're going to add in parallel and perpendicular into it. Parallel lines have the same slope. So to determine whether or not these are parallel, we're going to check to see whether or not they have the same slope. So in this first example, we have a slope of 2. This is written in slope-intercept form, so we can clearly see that. And this one's also written in slope-intercept form, so that one has a slope of 2. So these are parallel. In our second example, we have a slope of 1/2 here. It's written in point slope form. That's why I could just look at it and know. And this one is negative 1/2. Those do not match, so they are not parallel. For our third example, the first equation is written into slope-intercept form. Our slope is negative 3 there. And the second one is point slope form. We also have a slope of negative 3 there. So those are parallel.
Oh, sorry.
And for our last example, the first equation is written in point slope form, so we know that the slope is 3/2. The second equation is not written in slope-intercept form or point slope form, so my advice would be to change it to slope-intercept form. I'm going to do that out to the side. So to do that, we're going to isolate the y. And then after we isolate the y, or after we subtract the 3x, we're going to divide by 2 to isolate the y. That slope is negative 3/2. So those are not parallel because we had a slope of 3/2 and a slope of negative 3/2. So if we want to write an equation in slope-intercept form of the line that passes through the point negative 1, negative 2, and is parallel to the line y equals negative 3x minus 2, because it tells us that it's parallel, we know our line is going to have the same slope as this line. The slope of this line is negative 3, because it's written into slope-intercept form, so we can clearly see that. So since that slope is negative 3, our slope will be negative 3. So we have a point. We have the slope. We'll put it into point slope form. And then it says that it wants our final answer in slope-intercept form this time. So we do want to make sure on this one that we are distributing and then moving this 2 over to isolate the y and get it in slope-intercept form. Couple more of those. For this one, it asks for a line that's perpendicular. We haven't done that yet in this video. Perpendicular means they have opposite reciprocal slopes. So this slope, the line that it gives us, is negative 3. If our line is going to be perpendicular to that, then our line needs to be an opposite reciprocal slope. So instead of negative, it's going to be positive, and instead of 3, it's going to be 1/3. So our slope is negative 3. Our point is negative 3/5. We have the point and the slope, so we're going to put that into point slope form. And then we'll solve from there. One more example. We want perpendicular again, so opposite reciprocal slopes, but this time we don't know the slope of the line. We need to find it by putting it into slope-intercept form, isolating the y. So when I isolate the y, I'm going to subtract the 3x over, and then I'm going to divide by 6. So negative 3 over 6 is our slope. That reduces to negative 1/2. We don't really care about the y-intercept there. It's not important to us. What we care about is this slope is negative 1/2. And because our slope is going to be perpendicular to it, our slope needs to be positive 2. So our slope is positive 2. It goes through the point negative 2, 1. We have a point and a slope. That's enough to put it into point slope form. There's point slope form. Doesn't say we need to put it into slope-intercept form. But since I've done that on all the others, I'll go ahead and finish it out.